everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We got our debug system sort of in good shape over the past couple days, and wanted to probably start doing some feature cleanup. We have profile information currently being gathered, but we don't really have any way to look at it or use it productively. And so I'm not exactly sure what we're going to do today, to be completely honest, but it's going to be something along those lines. Either we will start in making the profiler, or try to start working with that to see how we're going to actually have the profiler work in practice. We'll either do that, or we will do something with just cleaning up sort of the way that we're drawing things. Because right now there's still some code in there that's pretty janky in terms of how we're displaying stuff and how things is being, laid out and all that. So we will give that a shot and we will see what actually happens. It's wherever the muse takes us. It's where the muse takes us. Because there's plenty of finishing things we can sort of do here in the debug system to get it into a good state, and the question is just which ones of those do we actually want to do. So I'm going to go ahead and launch everything up here, and let's see, going to load our Handmade project. Oops, that's no good. So in the Handmade project, if I run what we currently have built, we've got this sort of situation happening here, and all that sort of stuff and whatever. And so we've kind of just got this window here, and we still have the ability to resize the window, and we kind of have we don't really have any good drawing of borders or controls or anything at the moment. But what we don't have is any profile contents, right? And so one of the things I want to do is be able to get some profiling information here. And there's two kinds of profile information that I probably would like to have. One is memory, one is time spent. And so what I'd like to do here is get the profiling system back in some semblance of working order here, where we can draw something into the profile. And what I'd like to do, because typically there's really two kinds of profile information that I want to see. One is just sort of a generic profile that just kind of gives me a rough idea of who is taking what time. And so, I'm thinking I want something that just generally tells me the frames take this long, generally speaking, to complete, and so much of it is spent in the renderer, so much of it's spent in the simulation, so much of it's spent in the input processing, whatever. So that I can ensure that each of those things is looking roughly correct, and I don't ever have to wonder about, is there some weird spike happening where all of a sudden the simulation takes 3 times longer than it should and we don't know why. So I want that, right? And that's a very sort of high level, I want to be able to sort of have one of those in here where it's just going to show me that, and I can have that piece of information available. So I want that. The other thing that I want is I want the ability to, when we are actually optimizing a particular piece of code. So for example, if if we find that there's something slow and I want to fix it, then I want to be able to have something which shows me a detailed breakdown of what's happening inside that code, right? So we essentially have two types of profile information that we want: the high-level overview profile information, and then a sort of more detailed profile, which will tell me the information for an area that we happen to be working on. And generally speaking, I don't really need those two things typically at the same time, right? Meaning, I don't need the ability to just arbitrarily navigate down and check out some particular thing or any of that stuff. I don't need that sort of thing all the time. The most important thing is high-level overview that we can just kind of leave up on the screen at any time we want. And then once in a while, when I want to optimize something, I just want to be able to insert something into our debug blocks that says, hey, show me the profile for this piece of code in detail, and it'll give me all of the stuff that I want for that. So that's more or less what I want here. And so I think probably the most logical thing to do would be, since we sort of started on it before, would be to start with something that shows us, the profile information for the high level. So kind of like an overview-based profiler. And maybe that would be something kind of like the standard sort of profiler that you'd see like iProf or whatever. Like, for example, John showed the one that Sean Barrett wrote, and John had ported it to JAI. That's one that I think a lot of people use. And it's basically like a list of functions, and it says like, okay, here's a list of functions and how long they take and how long their children take or whatever. And probably how many times they're called. That's like a standard kind of listing-based profiler. So, something like that that's just kind of giving me a heads-up view of like who's taking the time on the whole seems like a pretty reasonable place to start for the overview-based profiler. And then, the other thing is we sort of have, I don't know, that profiler only really works with single threading, which is not so useful anymore. And so, possibly we want something that does like what we were doing with the bars, where we can sort of see when things were happening so that we have a little bit better idea of like the overlap and when stuff's triggering that's on multiple threads. I don't know. So that's generally where we're at. And that's like probably what we should work on today, I think. The other thing we could work on is like right now this stuff is sort of a little ad hoc, right? Like we have the ability to tear things off here, but they're sort of janky, and we just have these little nubs that you move around or whatever. And you can't necessarily read this very well. We don't have a way of like drawing, we don't draw like backing around it or anything. So for example, when we come in here, we happen to have a white backdrop here in this particular thing. Now that's not going to be common. We'll probably fill that in relatively soon, but it just underscores the fact that if things are bright, it becomes like harder to read this. And it would be nice if we had some kind of a dimming, something that would sort of dim that area more while we were working with it, if that makes sense. So that's really what I'm talking about, just these sorts of things. Some way of sort of cleaning that sort of stuff up. That's really what we're looking to do. So let's take a look at the profile stuff. That seems to be, the most underdeveloped thing at the moment. And we have to kind of go back and sort of figure out what we want to do there. Now, in the debug system, currently where we're doing our collate, we've got, let's see, collate, debug. So in our collate debug records code, we can kind of see the residual of the profiling stuff we're doing. Here are the frame markers, right? And the frame markers, we know what the wall clock elapsed is. That gets recorded with those frame markers. So we have the wall clocking information. We also have in here our begin block, end block stuff. And you can kind of see when we do our begin block, end block stuff, we figure out what these matches are. And we did this thing where we would build up regions. I don't really know if that's something we want to do quite yet. And in fact, I think maybe that's something I will sort of defer till later. I'm just going to go ahead and get rid of this for now. Well, actually, you know what? Let me just look at what this is doing in detail first. So if there's an open code block and we have an end block, then we're going to make sure that they match. Now, it looks like if spans go back before where we've got, we will ignore it, and that's fine. That's just if our debug information has passed where the thing actually started. But assuming that that's actually the case, and we've got a starting frame index that matches our frame index, and you'll notice here we don't sort of measure those, or we don't process those that started in one frame and ended in another, which isn't great. So we probably want to fix that as well. Then what we do is double check, I guess here, what the name is, and we only record a certain one that's being talked about in this particular case. So I don't really know what to say about this. I mean, that's certainly fine. But there's a couple different ways we might want to go. When we collate the debug records, at the end of every frame, we're running through these events, and we're sort of baking them down into something that we want to work with. And the thing that's interesting about this is we've got all of these events here. I don't actually know to what extent we want to bake them down and to what extent we want to leave them sort of more open. Now, we certainly could if we wanted to. Instead, like you can see here, we've got like store event, right? And so you can kind of imagine us taking a slightly different approach here. When we find these data blocks, these code blocks, we could treat them more like data blocks where we're just saying, oh, okay, we have these two blocks, let's go ahead and consider that span of time just like an event, basically, that we're going to store. You know what I mean? That seems like a pretty reasonable thing to do, actually. And so I don't know, maybe we're sort of approaching this the wrong way by when we do this collation. Maybe that's really not what we want to do at all, what we're doing here. Maybe we want to store these more like the data blocks. Maybe, in fact, we don't really want to treat these all that differently at all. Maybe the begin and end block can be unified in a way that would make it so that both of them go through the same sort of system, or at least a very similar system. And it seems like that could be possible, right? Because both of them could work sort of the same way. They could have a debug element that was, for whatever that code entry point happens to be. And, it could work from there. It's certainly tempting. And then these sort of records, each one of these would be have its own element. So every time we come from that, we see a begin block, we're going to find an element for it. And so we could just store the event to that element. I don't know, that seems really enticing to me. I kind of feel like that's the route we should go. It will certainly eat through our debug store faster, but who cares? It's debug. We can allocate 16 gigabytes for it and just be like, hey, guess what? We can store as much as we want because this is a dev machine, and we can just stack it full of memory if we want to track thousands of frames worth of debug data for some reason. And if we don't, doesn't matter. We'd only just have a few frames to look back, but that's okay. That, to me, sounds like a good idea. And I guess we'll find out why it's a stupid idea in a minute when I try it. But for now, we're just going to go ahead and do it. So here's store event. And I feel like, oops, that's not right. What's going on? Why am I not able to switch into edit mode? What's happening? Something real strange is happening. My shift key that was weird. My shift key was like locked down. Huh. I've never had that happen before. I've never had them on this machine or with 4Coder. I wonder if that was a keyboard bug. This is an old DOS keyboard 3. I've switched to the Razors everywhere else. I just haven't bought one for the Handmade Hero machine yet. So I don't know. We did have a problem. The DOS keyboard 4 totally had a sticky key problem, so who knows? Who knows? Anyway, it doesn't really matter. Point being, I'm going to go ahead and edit this. So I want to keep store event, and I'm just going to say, like, okay, whenever we open one of these begin block, end block situations, I'm just going to store whatever the event was to that element, right? Because we made the element and we have the event, and I'm going to store it. In this case, when we do the matching events situation here, again, I don't actually know why we're double checking these. I guess it's just because we want to ignore the ones that don't have an open block. But assuming it has an open block now, I don't care what the frame index is, to be honest with you, at that point. I don't care what the frame index is. I'm going to go ahead and do a store event, and I'm going to store event to the element that was in that matching block. So whatever the one was that we opened originally, I'm going to store it to that element. So now we basically have each element is going to have a open close kind of a thing, right? Now when I store these events, there's sort of this one additional piece of information I kind of want, and I'm not 100% sure how I want to store it. But what I would like to store, and this, by the way, now can all go away. This is goodbye time, like goodbye. So this is this event that happened is telling us when, in a particular point in time, like when this function got called, right? Or it doesn't have to necessarily be a function, right? We can time a block that's not a function, but when we entered this block. So here we're storing an event for when we entered the block of code, and here we're storing the event for when we left the block of code. So we will have like a little linked list in there of just entry, exit, entry, exit, entry, exit, entry, exit, right? That's what we'll have. Now, that entry, exit pattern, that will allow us to know every time this function was called and how, right? But what we wouldn't necessarily know is who called it, right? We don't necessarily know who called it. Now, we can reverse engineer who called it by sorting these things in temporal order or something like that. But we don't necessarily want to have to do that to sum up like what children were whose and that sort of thing. So what I suspect we probably want to do is we probably want to do some sort of a like, when we store an event of this type, we record who the parent was. Does that make sense? Like, we record which debug element was the parent, so we know which function. I'm basically talking about call attribution, right? Let me go ahead and make this a little more explicit here. So what we will have is we'll have a debug element, right? And the debug element will have a like thing that looks like this. So such that if we wanted to, we can basically draw a profile that just tells us every time it was called, because we know each of these, and we now know how long they are as well, and we know what frames they were on. So we have all of that information now in that like linked list. But what we don't know is who actually called it, because for all we know, a particular function that can get called from different places, we don't know which of those places was actually the call site that caused, say, this one. Like maybe this is a call, if this is a debug element for the function foo, maybe bar called foo and caused this one, but maybe baz called, foo to cause this one. And so if we later wanted to look at bar and baz in terms of like, oh, how much time is spent in foo on behalf of bar or on behalf of baz, for whatever reason, if we want that information, it might be nice to say like, oh, okay, well, we know that now, right? Look, we actually have some information in here that says, here is the debug element bar, or here's the debug element baz, and that's who it was. So like an additional pointer that we could use depending on what our circumstances was in the event storage might be nice. At least that'd be my guess. So if we look at handmade debug.cpp here, .h, and we look at that stored event. So in here, we've got just the frame index and what the event was. If we wanted to store an additional piece of information here, that might be nice. We don't have to do that quite yet, but I'm going to just make a note of it. Because we have that information here, but we won't have that information at any other time, right? Because the matching block could know who its parent was, because in the middle of this collation pass, we do know the answer to that question, but we won't know the answer to that question later when we're doing drawing, because we don't have any information, the information's gone, right? Because that information is only coming to us implicit in walking the array of events, because we saw the opens happen in order on this thread, and then we saw them close in order, so we know who called who. But once we leave here, we don't know that anymore because this array goes away. It's thrown away, right? Never to be seen again. So that's, that's how that works. And, again, it's sort of, again, an open question of just like, could we possibly do this a little more efficiently by just doing a giant stream out where we just write the events forever? And so then you're just in there and you could seek backwards to look who called you. Maybe, but I don't know. It seems like you probably want to collate periodically and produce these intermediate structures, because otherwise it just takes too much processing power, if that makes sense. So I think that's why we ended up sort of where we are. With you only want to collate the new ones for this frame, and you can't really afford looking through these giant array buffers all the time to figure out pieces of information you're trying to draw. So I think that's roughly it. I think that's all we're looking to do here. So, all right, so I'm going to go ahead and get that compiling. There we go. And now I'm going to go up to the profile situation, and I want to start looking at how I'm going to make this work. So after collation, and I guess once we're sort of once we're drawing these guys, then if I do debug draw main menu, oops, that's not actually it. That's the call to it. Here we go. When I do debug draw main menu, and here we are doing that debug draw of the main menu, and we come in here and we're doing our, and we're going to draw the element. When the element turns out to be a counter thread list or other sorts of profile stuff, this is where we need to start making these things work. So let's think about the different types of things we want to view. So the counter thread list, I feel like, is probably a good thing. Let's take a look. Handmade debug interface. Let's take a look at what we've got here. We've got counter thread list, counter function list. We don't really know what these are yet. I'm gonna go ahead and comment those out for a second and just see where we're using these. So we've got debug profile, we've got counter thread list here for just when we're printing things out that we don't want to print out. Counter function list, counter thread list is there. Okay. All right. I don't really know why element and event are even different anymore, to be completely honest with you. Do we ever actually call debug draw element versus debug draw event? So these are the same function, right? Like we don't, this is only from before when there was a question as to how we were going to segment this data up. So at this point, we really can just make this a single function, right? We can take this and we can stick this in here temporarily, just so we don't lose the code if we wanted, although there's really nothing there. It's the same as this code, so it's irrelevant anyway. But really, we don't need this anymore. We can just say that we've got one function. The function is debug draw element, and the stored event that we're actually passing here is something that we can just get. So we'll go ahead and say that that's that, and that simplifies this down so we don't have multiples of these. So, and I guess we've got in element here somewhere, right? Yeah, so that's going to be, I guess I'll just change that to be element. So if I call debug draw element like that, then really all we need to do is take a look at this most recent event thing. That's the one that we were drawing. So let's go ahead and just pluck this stuff out here. Get a create view for, we don't pass the view down, so we really don't need that either. So we're really just talking about this, right? That's the sum total of what we need to do there for the stored event. So there we go. What we need to think about now is what we actually want these to be. So what are the different kinds of profiles that we're going to do? So the first one that I want to do is, I guess, just that overview. So the overview, I think, should probably just be kind of like the basic kind that we were doing before, I feel like. Because again, since it has to be threaded, I think it should probably look like it looked before. And so the way that we might want to do that, I guess, is trying to think of how we would do that. So if here's the profile view, what we want to show is we need lanes for our threads. So maybe that, like, this is how we were doing that, right? So we have like threads going this way, And then we have like clock going this way. You know what I'm saying? And then in here, it's like function name is here. Right? I think that's what we wanted to do. That's what we were doing before. That seems like the smartest thing to do. And so what we would do there is we'd just use that open and close block data to draw these in. Now, like I said, it's a little bit tricky because what we don't have is necessarily a hierarchical. We don't really have necessarily a hierarchical layout of these yet, which is why I was thinking it might be nice to sort of have build that kind of flow graph up. And so I guess as we sort of implement this, that'll give me a good feeling of how we want to do this. So what I'm going to say here is I'm going to call this, I'm going to say that I want this to be a debug type, like what would we call this? A thread clock graph, I guess. Chart. How about a thread interval graph? Maybe, yeah. Thread interval graph? I feel like a thread interval graph sounds good to me. And so we'll go ahead and make that happen. In here, we've got this debug profile thing. That's the way we were saying what we want to do there. So what I want to do here is say, like, okay, I don't really want anything specific to happen here. So I'm going to actually make this very explicit and say that this is debug thread interval graph. And what we would pass here as a function name is if we pass, let's say, nothing. So if we pass an empty string, then maybe it just means show us the whole thing. Or if we pass a specific function, it would just show us that function down, right? That seems like pretty useful to me. So here we go in debug type thread interval graph, passing that through. We get the debug name of this thing, and then that's where we're at. So that will put it in there for us to use. And in this case, we're just looking at game update and render, so the platform code is not included. And maybe that's fine for now. It gives us something to debug. I'm not necessarily sure that's what I would do in the long run, but for now, that's fine. I mean, I'm not sure that's what I'll actually want up, is I guess what I'm saying. So I suppose in this case, we would never get to here anyway on these. So unhandled would probably be a good thing to print, actually. Probably so would open data block, to be completely honest with you. So let's go down here. Counter function list. This is not really code. Like I said, this code is not really proper. So we don't really care about saving any of that. And there's our interval graph. And so now we got rid of a function there. So we got rid of a redundant function. So that's good. And now we should be, so I guess we do print out like end block at the moment. Why are we printing that out? That's interesting. That is very interesting. I guess that's because we're calling store event. That's my assumption. Also, why is that twitchy? Do you see that? That's very peculiar. I don't really want to know what's happening there. Does it ever happen when I'm paused? Because right now the debug system's updating. So that's really peculiar. I don't honestly know how that can even happen. That is a real puzzler. So that warrants further investigation. However, what I will say now is, since we're almost down, since we only have like maybe 30 seconds till we run out of arena space, I'm going to let it run out of arena space as well, because I want to see what happens. Right. 5 megs to go. 4 megs to go. Almost there. Almost there. Wait for it. Bam. That is so peculiar. Let's make sure everything works besides these weird people here. Interesting. There is a handler for exception. The program is set to continue, right? X files rolling location. So there's a null. So the oldest, oh, it's just an assertion. The oldest frame somehow got set to 0. So there's something wrong with our oldest frame handling. Not sure exactly what it is, but we have a problem with it. So when we call store event and we come through here and we free these frames, right? We must be doing something wrong. Let's take a look at free oldest frame. You know what? Would you be a lamb and jump me there? Why can't I ignore this? I don't care about that. Set next statement. There we go. So oldest frame goes to the next frame. Which presumably there should always be room for, right? Yeah, I'm just not sure what's going on here. So we grab the oldest frame. We say whatever the oldest frame was, it's going to be the next frame after it, which makes sense. And if we're out of memory, which is when this happens, that means there should always be frames to free. We check out the most recent frame, and we see if it is also equal to us. And in that case, we would set the most recent frame to 0 as well, because that means there are no frames left at all. Now that's really probably something that we should assert on in general, because that should never actually happen, right? We should never free all the frames, because we would never be out of memory in that state. So this is like a thing that should never really happen. But anyway, then we free. So this would have been the line, assuming that there isn't some other kind of bug, this would have been the line where that would happen. Frame next would be equal to 0, and we would free the oldest frame. When we do new frame, I mean, yeah, I'm not sure how that happens. I'm not sure how we end up in the situation that we ended up in, where the per frame arena where there was nothing in the free store. Like, how is that possible? Interesting. So I'm going to do what I said I was going to do before and force that to happen sooner, because I don't like the fact that there's a bug there. And I'm assuming that that's actually not just a bug in general, because I did do, I suppose, this. Ah, okay. So we just have a bug. It has nothing to do with the arena. We just happen to have introduced a bug recently that occurs when we go into the game. That's all. Okay. Well, that's a lot more heartening. So I'm guessing that we've got something where part of our change to maybe how we were doing those event stores, maybe there were just two. You know what? I suppose there could technically actually have been so many events on a single frame that we couldn't store them all. Seems really unlikely, but I suppose it's possible. Like, it's possible that actually could be an accurate assertion, and that would be terrifying. But I guess I don't know how many of them there are, right? I don't know how many events there actually are coming through. So let's take a let's test it, I suppose. If we go to begin block, end block here, if I'm not storing these events, then we're fine. If I store only one of them, that's half as many. Still fine. And if I store both of them, or rather just that one, yeah. So I think that's actually an accurate assertion. It's just not enough memory. 32 megs is not enough memory to store how many events we actually wrote, which is kind of crazy. All right. So I guess that just means we probably have too many zones and things, but I mean, I guess that also means that when we do our debug start here, global debug storage size, we could just make that significantly bigger and then not worry about it, but that does mean we're probably processing too many events. So here's our debug storage size. If instead I said like, oh yeah, you know what, that's going to be bigger, much bigger. Holy cow, yeah. I mean, take a look at how fast that goes down. Right? This thing just chews through the memory. Very interesting. But once you give it enough memory to hold an individual frame, it does appear to be fine from then on. So that's good. All right. Okay, so the next thing we need to do is we need to fix this situation here, because I don't actually want those to show up in this hierarchy. They need to, so the things that are, those debug elements, right? Because we have, these. We actually don't want those to be added to the groups, right? We want those to sort of be handled separately. We really just want those to all go into a single group, really, and never actually be, always have a particular parent. And so in here where we do get element, oh wait, we're in the wrong file. We want to be in here. So when we come in here and we do get element from event, we want to be able to make that, we want to be able to force that not to do a hierarchical search for this thing and to instead use a specific parent for its operation. And so, when it's doing this sort of situation and it does the parsing, this get group for hierarchical name, we don't really want that to happen at all. And I don't really know to what extent we really call this. So it looks like we pretty much never really wish I could see what was going on here. Let's try again. Get element from event. There we go. So default parent group is what comes from what the data block is. And so I guess what we need to do here is get element from event, honestly, probably is just a little too heavyweight. Probably what we need to do is something where we can specify whether or not we actually want this to happen or not. So if we have the parent here, I mean, we could just add yet another thing. I don't know if it's going to be a little too bizarre if we have too many of these, but we can do something here where it's like, add directly to parent. So if we know that that's the case, then whatever the parent is that we're going to get, we know that we can say like, oh, okay, when we do a get group for hierarchical name, instead of actually ever calling this, we can just say like, oh, put it in the parent by default, and then if add directly to parent, is not true. Or I guess we could say, maybe do it the other way around. Get hierarchically, or create hierarchy. If that's set to true, then do this. Otherwise, don't. And that would work fine. So yeah, if I want to keep them out of the hierarchy, then what I would do is when we call get element from event, and I pass it the event here, oops. And I pass it the event, then what I'm going to do is I'm going to say create hierarchy is false for this particular circumstance, and the place that I want to put it is probably some special holding tank for these, which is like, profile group. And so the root group, which is here and holds all the stuff that we're actually looking at, that's actually going to be complemented by a profile group, which just holds our profile blocks. And then I don't actually know create variable group. This is just telling the size of this, so that is 7. All right. Profile group is not a member of debug state. You're correct about that, because I actually have to go in here and add it first. So root group is here, so profile group should be here, and compile. Get element from event. Get element from event is an ambiguous call. Is that so? Well, if it is, you know what I just realized? I have 2 overloaded versions of that function, which is part of the problem. Get element from event, cover not defined. Right, that's the problem. We forward declared that fellow. So now we need to make sure that we update the one of those. Get element from event. This right here is the thing that actually has to have the create hierarchy in it. we go. All right, so let's see here. This is tooling along, and so now we're still recording all of that information, but now it's actually being recorded into like the background where we can't actually see it, which is what we wanted, right? And so now, in theory anyways, I should be able to draw those things out by having whatever is going to happen in these groups sort of look into that profile data and pull out whatever is the part that they actually wanted, if that makes sense. So in order to do that, we already have this profile thing here, but we're not actually showing anything, right? So this information here, that's actually that sort of thread list business. We can now go and start to actually try to implement this. So in the thread interval graph, what we can now do is we can loop over the members of that that group, that element group, and we can actually draw those out. Now, I don't actually know how to figure out what the latest frame index is, but I'm assuming that that's actually something that we just stored here, because that's what I would have done, and I wrote this code. So I'm assuming that like frame count, for example, is just telling us what the indices are, and so whatever the most recent, well, you know what, we can just look at most recent frame, probably, and whatever most recent frame is, most recent frame probably has whatever its index was, right? Most recent frame. I meant debug frame. Yeah, so it's got that. So yeah, so I feel like that would do it. Now, frame bar scale doesn't, I don't know why that's there or what that was supposed to do. I'm assuming that had to do with storing how many threads were seen at that time. But this is probably just garbage now, right? I think that's just us doing some straight porting of the code. So yeah, that's just, I don't even know what that's supposed to be other than stupid. So that's fine. So yeah, so I think for draw profile in, what we want to do here is figure out how many frames to draw, how many frames we're going to draw, I guess. I guess maybe we'll just try drawing just one frame for now. And we'll try to adjust this so that it actually does something useful. So in draw profile in, here's where we draw sort of our background. Then here's where we loop over the frames. And I guess we loop over all the frames that we stored. That's not going to be very useful at this point, because looping over all of the frames that we stored is going to make it kind of prohibitively expensive, or not expensive, yes, expensive, but it's not going to be enough space, I guess is what I'm saying. So we're not going to be able to draw all the frames we recorded because now we've drawn too many frames, basically. So we'll have to figure out exactly what we want to do with that. But point being, we'll go through here and do maybe just one frame or something like that, and try to keep this a little bit simpler. I'll re-enable this here. I don't know what this is supposed to be. Render group, chart left, chart height. So this was drawing some kind of a like a underline, but I don't know why. Chart left plus 0.5 times chart width, and this drawing chart width, chart min plus. Oh, it was just, that was just the outline. Never mind. So we don't need that anymore. I can go away. All right. So let's see. Here's our our bar scale information, I don't know that we care about most of this stuff, but I think probably what we want to do is just simplify this down and say, okay, the frame that we're going to draw is the most recent frame. And I don't know, so it's the most recent frame. The thing that I'm not sure about is the most recent frame actually not filled in yet, because when we're doing this drawing, we've already advanced one frame. So do we really want the frame before that, or do we want this frame? And I'm not totally sure about that. I should look probably on Win32 Handmade at where the frame marker happens. So the frame marker happens after the debug stuff is drawn. So that means the most recent frame is really not done yet, right? So how are we accounting for that in the current system? In handmade debug.h, I'm assuming that collation frame is actually the one that's being filled. So I'm assuming that most recent frame is the most recent frame we actually have data for, in which case I think we're okay. So we'd start with that frame, and then what we'd do is we'd say, well, we know how long the frame took, right? Because we've got a begin and an end clock. So the maximum amount of time that a function could have taken that's inside the frame is going to be between that begin clock and the end clock, right? So we probably do something here like, R32 totals or frame span, equals the frame end clock minus the frame begin clock, or something like this, right? So if that's the span of the frame, then we now know that every piece of information that we might have coming out from those open close blocks, each one of those is just going to tell us some place inside that frame span, right? And I don't know. We've got the profile rect, so we have our pixel span, which is just the width of the profile rect, right? I don't know about the lane count, and so I guess I'm hoping that that is still a valid value, if that makes sense. And so if that's the lane count, then the rest of this stuff should still work, I think. Frame bar scale, I don't really care about at the moment. I'm gonna get rid of these and take a look at this. I don't care about the max frame situation. Pixels per frame plus spacing. Yeah, so I'm just gonna get rid of this at the moment. If the lane count is greater than 0, then I do want the lane height to work. So I think all this is reasonable here. Pixels per frame divided by lane count, though, that seems like that's not what I really want. What I want for the lane count is I want to just take the total height of the thing. And I get this is the right way to do that. I just want to take the total height of the thing and divide it by the lane count. So I'm pretty sure the lane height is just get dim profile rect y divided by the lane count. I don't think I want any of that. I think that's really all I wanted, if that makes sense. And that's how high the lanes are. So that's it. I don't think I want the rest of this stuff at the moment. And let's see, if we come through here, again, don't really want to do multiple frames. Don't want any of this at all. Uh-oh. What did I do? Okay, there we go. For some reason, I think I hit the wrong key. Okay. So now what I want to do is I just want to spin through each of the things in the profile group, right? I've got that profile group that has essentially all of the, this right here has all of the things that are in the profile. So I've got debug variable link, and that's going to be profile group children dot next. Link is not equal to profile group children link equals link next. That's going to be each of the elements that comprises a function call, or a timed block, if you will. And so really all we want to do is recompute this part right here based on the open close block information rather than the other bits. So for our stored events, here we go. For our stored events, we have the oldest event and the most recent event, but they're not a doubly linked list. They're only a singly linked list, which I don't know if that was a particularly smart idea, because it seems like you want to be able to walk them in either order. But for the time being, we can still spin through all of them, I suppose. What we want to do is we only want to know what the most recent and the one just before that was. Or rather, we just want to walk the ones that are in this particular frame. So I'm not sure exactly how we walk those, because like I said, we haven't really dealt with these in a while. So let's take a look at who actually uses these. So if we go to the most recent event, it doesn't look like we ever actually iterate over them anymore. But here's store event. So you can see that if there's a most recent event, then it's most recent event equals most recent event next result. If there isn't, then they're both equal. So what that means is the most recent event is the tail pointer and the oldest event is the head pointer. So it starts at oldest event and goes to most recent. I don't know why we didn't doubly link those so that we can walk them in either order. That's kind of not clear to me, to be completely honest. Because it seems like we would want to do that. So I don't know, we might want to change that to linking them both directions, but who knows? Maybe we want to build them in some more complex order just in general, because it is true that maybe we want them to be in the more hierarchical, maybe we want to build a tree out of them or something in the future to accelerate these sorts of things if we were being fancy anyway. So who's to say? But anyway, so if we're in here and we want to draw rectangles, what we would do is we'd say, well, okay, the debug element, which is the profile element for these guys, we want to make sure that it always has one, because that's the only thing, these links are always supposed to have those. And assuming that it does, then what we're going to do is we're going to say, for each of the stored events in here, as we go through the events, what we want to do is we want to look to see if the event is what its frame index is the frame that we're actually on. And if it is, then we want to either draw it if it's a close event, or set, like, keep track of what the interval is if it's not. Right? So trying to think here. If it's a frame, if it's one of these, basically what we'd say is we'd say debug stored event, open event equals 0. And so we'd say if it's a frame, if it's one that we recognize, right? If it's something that we recognize, and I guess we can even move this. This guy can be inside here. If it's one that we recognize, how much time I got? 4 minutes. Then what we want to do is say if the event type is an open event, I don't really remember what that's called. Begin block. If it's a begin block, then the open event is going to be equal to this event. And I guess we can dispense with the stored part of this, probably. If it is a closed block, then we would just say, like, if there is an open event, right, then we can draw. And I suppose we could even do it this way. Then we can draw it. So if we had previously had an open event, now we've got the close event that goes with it, and so now we know exactly what the interval is, and we can draw it on the chart. So if that's the case, then we know the clock, right? We know the clock value here for it, so we can use the clock to place it directly into the location that it should be. And we know the we know the thread ID, so the thread ID can also tell us where it would go in the region. So I don't remember how to look up the lane index for things. That I don't recall. And one thing that we probably would want to do actually is replace these thread IDs when we store them. We would want to replace that with an ordinal for the thread rather than the thread ID, I think. Because the thread ID is coming from Windows, we want to rewrite that with some well-formed ordinal. So that's probably to do, KC, replace thread ID with a well-formed ordinal at collation time. Because that seems like something we don't really want the Windows thread IDs at that point. We want to regularize the thread IDs down to something that we can use. So let's ignore that problem temporarily, because I'll do that tomorrow. We don't have time to do that today, I don't think. It won't take long, because we already do it in the collation. We just don't store it. But anyway, if we find them, then we would know, like, okay, the place where this thing is going to be, the min-x and the max-x are just going to be placing those clocks, the frame span. We just need an inverse frame span here, right? Or rather the frame scale, right? So to compute that frame scale, we just need to know that the pixel span is, that the frame span is non-zero. So assuming that it is, so that we took some time, assuming that it is, then what we need to do is we need to say that whatever the pixel span is how big we want things to be if they take the entire time. So we want to do the whole pixel span, and we want to shrink down the frames time to equal to the unit, right? So we want to say, like, okay, however big the frame span is, we divide by that to regularize everything to be between 0 and 1, and then we multiply by the pixel span to blow it out to the right number of pixels. So that's the entire thing for the frame scale, going from the frame span to the pixel span. So all we have to do here is just say like the min x is just going to be whatever our profile rect x is, and then that's going to be plus the frame scale. I guess we just called it scale here, so I'll leave it that called that. We're going to have that scale times for whatever the open event was, that clock, minus the frames begin clock, because that gives us the sort of the ordered version, right? The based off of the beginning of the frame. And similarly, the profile rect y's scale, we want that to be I'm sorry, the max x rather. We want that to be the close event, same thing. So that's that. I'm just gonna change that scale. Not a great word. Not a great word, but oh well. So that's scale. Then let's see. What else we've got is we have the y's have to be fixed. So let's see here. Oh, that's debug state. Oh, right. I think that's the way these work. Okay. So yeah, region. I don't know that this is something we can really do much about at the moment, so I'm gonna leave that as an undone thing. Profile rect, we need our, I guess it's be our min x. Left of clock, I agree with that. It's that and that. So we need our open event. We should probably just also introduce a close event, which is just the one we just found. Stack y is undeclared identifier. That's true. So how is this working here? We've got lane the lane index. So we don't know the lane index at the moment. So that's just going to have to remain like so. Something like this. And we know the lane height, so this is just going to be the profile rect min y. Or it looks like we're coming down the lanes from the top, so it's actually going to be the max y, is the way we did this. Right? Missing parentheses. Is that so? Yeah, that is so. Push rect. We've got a region rect, 00 v4, R2 v4. What's the problem with that? Render group is first. Is that what we're talking about? Render group star object transform. We don't have an object transform. So this is actually just old code, basically. So here's what we actually need, right? And we've got this this no transform thing here, which is what we would want to use. There we go. So in fact, we could just do this, right? Can look at this here. That's what it actually has to be. We've got our no transform, our region rect, and then our colors. So there we go. So that's all good. This record, I guess we just use open event at the moment. And see what else we got. Block names, not a thing. In fact, I don't really want to look at this right now, to be honest. This is just really going to format the information for the record, so we can do that in a bit. Let's go ahead and recompile. All right. So that's where we'll leave it for today. We won't go any further there. Oh, that's amusing. That's actually correct. Hilariously, I think. You can see that it's yeah. We don't have any way right now of actually ensuring that we're drawing in the correct order, to say the least. But okay, so I'm gonna leave it here because we've got more work to do a bunch of stuff. We have to get the sorting order right, and like I said, possibly have to do some hierarchical stuff because we don't really know. In order to draw these, we don't really have any information, unfortunately, about like we don't have any information about who calls who, and so stacking these up is going to be a little bit tricky, to say the least. But we're getting there, so we'll pick that back up tomorrow, and for now we'll go to some Q&A for a brief period here. Also, I suppose if I take a pointer and I convert it down to something that we can use, like this. Must have. Yeah. Kurt Jansen, what do you think of using a call tree to track dependencies across multi-threading? Well, if you're talking about the profiler, so the problem is a call tree doesn't really help you. What we actually need to know is which set of calls goes with which parent call, which is kind of tricky. I mean, we can actually have, like I said, I'm thinking of storing actual parent pointers for each one, which at that point is sort of a call tree, but it's actually like it's more like it's actually tracking every single call as opposed to just a a typical call graph just has this function gets called from this other function sometimes, right? So yeah. What command do you use to change from cutscene to game? I was the spacebar. Tomorrow is episode OXFF, that's true. Expansion pack, how do you handle tasks that run in separate threads but take longer than a frame to compute? For example, I heard that in the new Forza, the rear view mirror updates at half the frame rate as everything else. That's totally fine. At the moment, we wouldn't be drawing those, but we can do that as soon as we get all this stuff straightened out. It's not very difficult because if you look here where we say like, oh, if we found an open event, if we didn't find an open event in this frame, but we found the close event in this frame, that means that it was running since the previous frame, so we could just draw from the beginning. We just hard set this clock value to 0, right? Or sorry, this offset to 0. Naysayer88, why was I not informed that Krampus is in this game? Are you kidding, dude? I sent you the picture of Krampus before I think it even was shown on this stream. You have like an email in your inbox of Krampus. I'm pretty sure. Maybe not. I don't know. I thought I sent you the picture of Krampus. But he's in the game, man. Krampus is not just in the game. Krampus is like the reason the game even exists. Because Santa Claus is basically just a dick, right? Which is true. And he doesn't like understand that a little boy that doesn't have any arms is not going to be very happy just getting hats all the time. Like, he needs to be able to like get out and like do stuff in the forest and like have adventures. And so when Krampus comes and he notices that, he like totally saves the day by giving the kid, because, you know, as you know, Krampus dismembers children. That's what he does. So he'd have a lot of hands around in his sack to give to the little kid so that he could have a hand now. And that's exactly what he does. So it's basically like Krampus is great. I mean, that's basically the moral of the story. DeFreaky, is talking to the chat while coding helpful to work things out? No, it's the opposite of that. Talking while coding makes it really very, very difficult to code, and I find that a lot of times it's hard to do complicated stuff while I'm talking, but I do the best I can. Do you have a problem with Santa from your childhood? Yes, actually, I do. When I was little, like, my mom took me to the grocery store, and I was in the little cart. You know how like you sit like a kid in like into the cart, and their like legs dangle through, and they like sit facing backwards, I think, so they can see their parent who's like pushing them around. And like this weird like dude dressed as Santa like waved to me and said ho 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 or something at Christmas time, and I didn't know what that was, and I freaked out, and I screamed, and I like banged my head like my mouth on the bar of the grocery cart, and my teeth went into my lip, and I like bled everywhere. So like Santa's like no good. Like, Santa is just not good. We should have Krampus mostly and celebrate Krampus things, and then Santa is like, forget, Santa is not good. Santa should not be allowed to be in games other than as a villain. All right, John is saying that he didn't get a picture of Krampus. Did I only send Santa? I sent a picture. I'm going to go back and find it, but I sent a picture, and I thought it had Krampus in it, but I guess I'm wrong. I'll look, though. Did you consider visualizing timing using flame graphs? Well, in case you haven't noticed, we're just starting to draw profiles now, so something as advanced as a flame graph is going to require a lot more code to write for an in-thing profiler. So we could consider writing a flame graph further down the line. I don't think I will, because we certainly don't need one, and it's just going to, we've spent plenty of time on the debug system already. I wanted to spend time in the architecture of it, so you could kind of see me working through a bunch of weird trade-offs and see how that goes. But spending a bunch of time making gratuitous graphs is not probably a super good use of stream time. So I don't think we would probably ever write a flame graph. They don't give you very much actual information. As a visualization, they're kind of, like I said, a little gratuitous. It's not to say that they aren't helpful, but it's like, in terms of actually needing a flame graph to do to profile your code, there's almost no case where it's like I couldn't have gotten the information I needed from a simpler graph. And I think a lot of times the only reason you would ever really need a flame graph is if you were in some kind of nasty, super nasty, crazy code base where you couldn't tell what was going on. Maybe that helps you, I don't know. But they're not super necessary, right? Is this software rendering the frame time is tanked? No, it's not software rendering. I think it's just going through the like ridiculous number of debug for elements, right? We just have way too many debug elements to sift through at this point because we're recording arbitrary numbers of frames, right? That's why I said like we kind of have to not do this the way that it's being done, because this has to loop through every frame every time, every event every time, and there's hundreds of thousands of them at this point. So it's going to be way too expensive. So that's why I say I'm not really sure exactly what we want to do about that. But we'll need a faster way of querying the information that we need, because basically all of the time is in this. If, for example, you were to just get rid of this, right, then I think you would be fine. Why did that not reload? Oh, because it's saying unreachable code. Thank you so much for telling me that that code is unreachable and not actually building my game. That's what I wanted you to do. There we go. So you can see if you just disable that search, right, then you're okay. But we definitely have some kind of a string problem because our strings are guarded now. Like we do push them on here, but you can see that we're not actually getting, like, that got across the reload, it broke. So something is not getting pushed on properly, and we should figure out what it is, because that's a bug. Right? Because code reload should work now, and it mostly does, but these are not being pushed on properly. Looks like we're done with Q colons. I need to scroll back through and see. See here. Yeah, I think we're good. All right, so let's go ahead and close down here. There we go. And yeah, so this is what we'll work on tomorrow. We've got to get that going. I think really so we just need to figure out what data structure lets us draw some useful things that doesn't throw out too much information. We definitely can't afford to search it all the time. We could just double link those lists so we can just look at just the current ones or whatever, but I'm not certain how that has to go, if that makes sense. Agnes Holder, do you have a secret phobia of writing game code? Not really a secret phobia, but I definitely don't like it. Like, there's no question that will be the least fun part of the stream for me. I don't really like game code, because that, in my opinion, is for a game designer to do. And I am not a game designer, I'm an engine programmer. So, you know, we'll be out of things to do in the engine before too long. But, yeah, am I interested in writing game code? No. I don't really want to do it, because that's not what I like to do. And so typically, like, the, you know, the parts of game code that I'll enjoy are the parts that were actually implementing engine pieces, but which are you know, premature to do prior to the game code. So like some animation code and code for how we handle, you know, just storage of the entity or stuff like that. That's, you know, code that I'd like to write. But code that's like actually gameplay code, like, you know, what should this enemy be doing at this point? Like, I don't like writing that code at all. Like I said, that's really for game designers to do, and not me. If that makes sense. Game code is for game designers, not for engine programmers. So I'm going to close this down, and yeah, we got, like I said, we still have more stuff to do before this debug system is really correct. And to sort of, I guess, answer the maybe perhaps just that question is, I'm not writing more debug code because I don't want to write gameplay code. I don't want to write gameplay code, but that's not actually why. The reason is just because until the debug system is satisfactory to me, I don't consider it done, right? And I don't plan on really revisiting the debug system much. Certain things like collision detection, we did a little bit of just to have it in place and sort of see what was there, but it's not like done, right? But I'm planning on wanting more game code in place before we go back and make the final one of it. Whereas the debug code should just be, this is we know what it's going to do, so we don't really have much more information we need out of it. So I want it to actually be done to my satisfaction before moving on. And like I said, this was one where I decided to do things. I wanted to show how to work through architecture stuff. So this is stuff that is not the way I've ever done it before, possibly not the way I would do it again either. I just decided to try some different things and see what we would end up with, if that makes a sense to y'all. So yeah, so no, because there's plenty of other engine stuff we can do. It's not like I have to do the debug code and the only other thing to do is gameplay code, because we've got a couple other things on the to-do list that are definitely not gameplay code. That makes sense. So, Gary Johansson, can we make games in Game Maker and submit them to you for the final game? No. The game is designed. I did that. It's done, and that's what it'll be. Like I said, the gameplay code is not that interesting to me because that's basically like, you know, what was I going to say? Yeah, it's just like, oh, you know, how exactly should this thing do what it's doing in terms of feel, or should this enemy like attack this guy, how frequently, or something like that. That stuff is, you know, you can't design that on paper or anything anyways. And you want like a game designer to do those things. Like that's what they're supposed to do. That's their job, right? And so I don't really want to do those things because that's very game design-y. And so normally I would just say that's the game designer's job to set all that stuff. But in this case, there is no game designer here because I'm doing the whole stream, obviously. So, you know, that's the way that is. In terms of tuning, we can always, if there's things that are easy to expose as just a variable, then that's simple, because then you can always just leave that and send it to somebody who's a good game designer after we're done and be like, tune these variables as necessary. But that's not the hard part. The hard part is more more intricate decisions about what's happening in the code, like, you know, about the actual, maybe like, I don't want to say AI programming because that's kind of a loaded term, but I mean the like game behavior programming. Making the decisions about what the enemies are going to do and when and how exactly, right? There's how do you program that well, and I can show you how to do that, but there's how do you make decisions about what it should do in terms of making the game the best game, and that is not in my purview, right? That's not my area of expertise. So that's the sort of stuff that I just don't enjoy because I'm not versed in it and I don't have anything to add. So it's going to be, on the stream, it's going to be like, well, here's what this enemy does because I said so. And if you want to know what the enemy actually should do, you should go talk to somebody who's a good game designer and ask them, and hopefully they can explain it to you because I'm not going to. That makes sense. Abner is asking me for people to stay on the chat. after I am done, which is I am done. So I guess he wants me to say stay on the chat. I don't know why you should stay on the chat. Abner, do you want to tell people why they're supposed to stay on the chat? I don't think people are going to be that interested in staying on the chat just because I said so. Because I'm leaving the chat. So it would be weird for me to say like, oh, hey, you should stay on the chat while I don't do that. Abner Coimbray, it has to do with Juan 3D and an interview with him. Well, why is that not just announced then? Does someone want... What's going on? Why would you have a secret interview with Juan Chun? Why wouldn't you just say we're going to have an interview with Juan today? Here's when it is. Something's up. What is up? Somebody tell me what's up. Okay, wait, you're going to stream an announcement of an interview? It's not a live interview. What? I don't even know what you... Okay. Ladies and gentlemen, I'm going to close down the stream. I have no idea what's going on in the chat. I feel like probably what's happened is that Abner has had too much chocolate wine and now believes that Juan Chun is talking to him from New York City. It's sad, really, but that appears to be what has happened. I don't know. I've been asked to ask you to stay in the chat, so I asked you to do that. You should feel free to assess the level of drunkenness that Abner is currently at for your own sake, for your own, using your own judgment, and then you can decide whether to stay in the chat. I will tell you that Juan Chun is somebody worth watching an interview with. However, this is the first I really have heard that there was even going to be an interview, so I don't even know what it would be on or what it's about. I have nothing else to say. But if Juan is going to be doing an interview on something, that is probably going to be interesting. He knows a lot of computer science-y stuff. And so any sort of theoretical things, it's usually... I would assume if he's going to be talking about anything computer science theoretical, that would be pretty interesting, but I don't actually know because Abner hasn't said. So anyway, that's what's going on. And now I will close the chat down and let I'll close the stream down and let the chat do whatever it is that the chat is going to do. And I'm mildly terrified. But I have to go to dinner, so that's, I guess I won't even get to find out what the situation is. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with source code, you can always do so by pre-ordering the game on handmadehero.org. It comes with the source code so you can follow along. You can also go to our forum site to ask questions if you have questions you want answered. That's a good place to do it. We also have a Patreon page if you want to support the video series. We have a tweet bot. You can tweet you can subscribe to that if you want the schedule tweeted to you so you can catch the live stream. And speaking of the live stream, we'll be back 5 p.m. Pacific Daylight Time tomorrow. Until then, have fun programming, and I will see you guys on the internet. Take it easy, everyone.